Okay, friends, welcome to the first lesson of Max Min chapter. So this is chapter 4 or 5, and today we're going to look at and review polynomial functions and also learn some new vocabulary with the intent of having a graphical visual for Max Min optimization problem, which is down here. Okay, so here we go. Let's get in. So, there's going to be some new vocabulary today, which you'd be good just to practice and use as you're interacting with each other and with me, and also reflecting on your thinking as you're making sense and reviewing past content. Okay, so today we're going to be looking at critical numbers, local max mins, increase and decrease, and being able to graph them. Okay, so okay, so today what I'd like you to be able to do is graph this without finding the x-intercepts, and graph this by finding the minimum or maximum value using the y-intercept to approximate the graph. Okay, and we'll also look at that one as well. Okay, so here we go. So first off, we need to do a little bit of review. You need to make sure that you know when a function's even and when a function's odd. So please pause the video and answer these questions, and then check in. Okay, welcome back. So we know that even functions have two ends of the functions pointing in the same direction. So all these would be examples of even functions, and if they're pointed down like that, it would still be an even function. Whereas an odd function could be a straight line, it could be a cubic, it could be an upside down quintic, like so. But the key being is that there's an even and odd number. There's an odd number of arrows pointing up or down. Okay, this will also cause some issue right here. Notice that in each of these pieces here, they all have the same x-intercepts, but very different things happen on the graph. So let's look at that. Let me just clear my screen here. So I think we've covered positive and negative functions. We've also covered even odd. So now what I want you to do is look at this. This function here has two x-intercepts, which is the same here. They all have the same x-intercepts, -1 and +1. But what happens when the degree is 1 here, it essentially goes through it in a linear fashion. It's not truly a linear fashion, but it's like a linear fashion, and it just goes straight through. Whereas notice this one. This has degree 2, and this little piece of this graph almost looks like a parabola. It's not a perfect parabola, but it looks close enough to it. And so that's what the graph looks like. If you would like more practice with this, please experiment with Desmos. And of course, this graph right here, that piece right there looks very much like a cubic function. And what a surprise, the multiplicity here is 3. So that's the first piece of warm-up. And then what I'm going to ask you to do here is let's look at these two graphs here. Ooh, that got away from me. So we'll look at these two guys, and what's the constant term? So let's review the terminology. And the terminology here is that there's your constant term. Another name for this is the y-intercept, which you know the leading coefficient is -3, which tells us that it's a negative function. We know that this function is odd because the largest power is 5, or here, the greatest power of all the exponents would be 1, 1, 1, and 2, and you add those all up together and you get 5, which is consistent with that guy right there. The multiplicity has to do with the number of repetitions of the x-intercept, so that one has 2, 1, 1, and so on. So now what I'd like you to do is do a quick sketch of this graph here. Okay, so pause the video and sketch this to the best of your ability, and then we'll come back and chat about it. All right, so let's take a peek. So we know that the x-intercepts are -2, -1, 1, and 2. We know that the y-intercept is, let's see, it's going to be -3 times 2 times 2 times 1 times -1 times -2. So the y-intercept is -24. Okay, and so if we were to graph this, we also know that the degree is 5, and it's negative. So that means it's going to go down like that, like this, or like this. Maybe there's a couple jumps in there. And so I'll show you what the graph looks like. Look at this. Here's our -2. Here's our -1. Here's our -24 right down there. Here's our +1. Here's our +2. Since we know it starts in this quadrant, that's how I know it starts up here. As we come down the graph, we're going to do a little bounce make a little parabola because of the degree being 2 there. Then we have to turn around to go through the 1. We have to go all the way through the 24. We have to come back up through, and it's got to go right through the 1, and it's got to go all the way, and so on. So now this is a horrendous graph. Remember, I'm using a mouse to demonstrate this, so please, this is not a proficient graph. This isn't even a function because of how horribly I've drawn this. What I want you to think though is today's challenge is, how do we know how high these points are here? Because when we did this in Math 12, we were simply approximating that by testing values in here. And I ultimately said, don't worry about how high that is. But today we can find exactly how high those coordinates are. And that's what today is about. And so just to prime you for that, tell me everything you know about this coordinate here. Well, you might say things like it's sort of at the top of a peak. It's not the absolute maximum, but it's a local maximum or a relative maximum. You might say that the slope equals 0. And you know how to find, you know how important that is. So there's a couple places where the slope equals 0. Okay, so I think what we're going to do is get you going. And maybe we'll just talk about a couple new terms here. Intervals of increase. So when we look at this graph, there are times where it's increasing. And basically what we're saying is the first derivative is positive, or the derivative is positive. Okay, so that's where it's increasing. Interval of decrease, it goes down, and a critical number is a place in which the first derivative is either equal to 0, so it would be equal to 0 there, or the derivative is undefined, and we haven't looked at that yet. We'll look at that next time. But a critical number is a number in which the derivative is 0 or the slope is 0. And the reason it's critical is because it tells us where it turns around. So we're going from increasing, goes through the 0, and now decreasing. Goes through the 0, changes from decreasing to increasing. So they are critical numbers. They're telling us key information. Okay, so we'll start off with challenge 3, but first please do a self-assessment on your ability to, with the terminology, and also your ability to graph functions using the first and second derivatives. Okay, so we're going to pause here just for a sec, and we'll be right back. Please try this. Please try these questions without me, and then I'll talk. Okay, describe what's happening to the function within each interval. So do you see that this slope here is 0 and this slope here is 0? So when x is less than 2, there's something clear happening in this interval, and that's that it's increasing. And when x is in between 2 and 5, something else is happening. It's clear. It's descending. It's decreasing. The slope is decreasing, and you can see beyond 5, when x is bigger than 5, we are increasing once again. So that's what you're learning right now. What does increase, decrease mean, and what are the critical numbers? The critical numbers here are 5 and 2. And we can see that right there. What I'd like you to do right now is sketch this graph by plotting the y-intercept, the coordinate of the vertex, using calculus, and approximate the rest of the graph. Determine the intervals of increase and decrease. Okay, so let me show you how we can look at that. Okay, first off, what we're going to do is we are going to approximate the graph. We know it has a y-intercept at 1, and we know it is a parabola. So it either looks like this, or maybe it goes down further, or maybe it's over here, or something like that. So that's the challenge, but we know it's a parabola that opens with 1. What I'm looking for is that coordinate there, the minimum value. What I'm going to do is I'm going to take the derivative, set the derivative equal to 0, and now solve for x. And when I do that, I get an x value of 6.25. So when I look at this graph, I know that it's going to be over here somewhere. So I know somewhere along this line here, somewhere along the line here, the slope is 0. Now I need to find that exact coordinate. So I want you to think about, what would you do to find that coordinate? I hope you're saying put this value into the original function to find the y value, which is what I'm going to do. Now we've plotted the y value. And then we've stated the critical number at 0.625. And then we found this value here, the y value, by placing 0.625 into the original equation. So we know that. And we know that that's the lowest point, and we know it has to go through that y-intercept. So of course the graph is going to look something like that, which is what it does. Okay, and there's our graph. Let's look at another example. Now, later on, you're going to be looking at functions where you don't know what they look like. And because of that, you need to learn how to use the interval notation. So let me show you what I mean there. So notice on this graph, we found that the critical number is 0.25. So on a number line, what we're going to have is 0.625 on the number line. So I want you to pretend we don't know that it's a problem, we don't know what it looks like. So either it's going to be increasing on this interval or decreasing. So all I'm going to do is choose a number that's less than 0.625. So it could be 0, -10, -100, any number, and we're just going to put it into the derivative. And when we put 0 in there, we're going to get -5. So the value of the first derivative is -5, which means that it's a decreasing interval. So it's going to go something like this, which means it's decreasing. And then we're going to try any number larger than 0.625, 10, 100, 7, 2, 4, 1, whatever. In this instance, we tried 1. So 8 minus 5 is 3. So that's positive. So if it's positive, then we know it's increasing. And so this is what we have. And we can interpret that it's decreasing. So when we look at that graph, we know we can make we can determine whether it's increasing or decreasing even if we don't know what the graph is. Okay, we have another challenge here. So this time we're going to sketch this guy by plotting the y-intercept, the coordinates of the relative max and mins, and then approximate the rest of the graph and determine the intervals of increase and decrease. And so we could do that in a number of ways. And so since I know what this graph is going to look like, I'm going to do things like, hey, I know it has a y-intercept at 1, it's positive and it's cubic, so it's probably going to look something like that, or it could look like, there's my 1, maybe it goes up and down like that. It's something of that nature. So what we need to do is figure out where is the slope 0, and then find those associated y values so we know what it looks like. Okay, but we already know it's going to increase, decrease, increase. We can see that. So let's again, so what we're going to do is we're going to take the derivative of that, and there we go, and we're going to factor it. We're going to set it equal to 0. We're going to state that the critical numbers are x equals -3 and x equals -1. Then we are going to plot the y-intercept. We're going to plot the critical number. So that just means that somewhere along here, the slope is 0. So if we think about what I thought it looked like, I didn't think too deeply about it. I just thought it probably looks like that. And it's actually on the other side. So that tells me a little bit. Yeah. Okay, so then what we're going to do is we're going to put the -3 and the -1 back in. And when we do that, we find out where those coordinates are. So when we put -3 in the original, notice that we get a +1 out. And when we put -1 in, we get a -3 out. So we know that this is a cubic function, and it looks something like that. So it has to start down here. So that means it's got to go through here and turn around right there. And it's got to come here and go turn around right there. And then it's got to go right through just like that. Okay, and of course, that's what the function really does look like. Okay. So there you go. That's what the function looks like, and we can state the intervals of increase and decrease very easily from that graph because we know what it looks like. I do want you to practice using just intervals and testing values. That's an important skill. So we're going to do that right now. Okay, so remember that when we took the derivative here, when we took the derivative of this thing here, here's our derivative right here. We also have 3 intervals. The intervals are when x is less than -3, in between -3 and -1, and larger than -1. Remember, those values here come. That's a critical number, and that's a critical number. So now all we're going to do is just test a value in this interval, because we know that when you happen to know what the graph looks like, but on this interval to the left, every value there is positive. All the slopes are positive. It's positive the entire time. So all we have to do is test one value, and that is enough. So let's choose a number that makes sense, a number that's less than -3. I'm going to choose -10. So if I do that, if I put -10 in there, that whole thing will end up being negative, and so will this one. So I'm going to have a negative times a negative. And a negative times a negative is a positive, and if it's positive, if the first derivative is positive, then it's increasing. Now I'm going to choose a number between -3 and -1. How about -2? So when I do that, when I put -2 in here, this guy will be positive, this guy will be negative, so I'll have a positive times a negative, and when I interpret that, it's going to be decreasing. And then I'm going to choose a number larger than -1. How about 0? So that's going to be, that'd be positive, that'd be positive, so positive times a positive, is positive, so it's going to be increasing. And just like we already know, we knew that this graph looked like that. And so we can see that it's increasing, decreasing, increasing. Okay, so that would be an important observation just to make. And we could easily say where it's increasing and decreasing because we've already set that up. So those would be the skills that you should have. These are the skills that you should have at this point. And so I hope that this video helped you understand that. And let's see, is there anything more on this slide deck? That's it. Okay, so we're going to end the video there. I hope it was helpful, and best of luck. See you soon.